distance between us ain't no mistake. I'ma tell you.
Welcome guys to today's class. In today's video, we want to discuss alkene under ozonolysis of alkene. Remember that alkene is one of the organic compounds we have. We call them one of the unsaturated organic compounds. Unsaturated because they can go into reaction easily, and also because it has two bonds, one sigma bond and one pi bond. The sigma bond is very strong, the pi bond is a weak bond. So because of the weak bond it has, that is why it can go into reaction easily, because that pi bond can easily break down, will go into reaction easily. And so we want to look into ozonolysis of this alkane. Ozonolysis of alkane is one of the reactions any given alkene compound can undergo. We have numerous reactions they can undergo, but we want to discuss the ozonolysis aspect of it. Yes. Now, it is important to note that for a reaction to take place, conditions are required. For a particular reaction to take place to produce a product, to give rise to a particular product, a particular condition must be required. Once the condition is not met, it might not produce it, or it will not produce that product. It will give another product, so to speak. Now, for this ozonolysis is gotten from a compound called ozone. It means when alkane is reacted in presence of what? Ozone. Ozone is triatomic oxygen, O3. Now, it's important for you to know that for this reaction to go well, it will take place at a very low temperature of about 78 degrees Celsius, and in presence of methanol. Now, once these conditions are met, this alkane will break. How does it break? It will break to produce an unstable compound, a compound that is not stable. How? Okay, look at the compound. This is what we call molozonite. It is unstable. And because it is unstable, the fragment of it will try to recombine to form ozone. It will recombine to form ozonite. Look at how they recombine. This is ozonite. This ozonite too is also unstable. They are unstable, they are like gaseous, in gaseous form. So it forms this from here, it forms this, they are just unstable in a gaseous form. Are you getting it? Now, once it forms this, when you bring in catalysts like zinc here, when you bring in zinc, or you bring in or even when you bring in dimethyl sulfide, any of these catalysts, if any of this is put into this reaction, it will be forming either an aldehyde or a ketone. What do we mean by that? We say either you bring in zinc, this and this. Any of it, not all of it that you bring, any of this is what you can bring in. When you bring in, this is dimethyl sulfide. Dimethyl sulfide. Look at it, dimethyl sulfide. That is what we call this. Look at how we write it. Dimethyl sulfide. Either you use it or triphenylphosphate. Triphenylphosphate. Or you can equally use zinc. Any of it can work out. Okay? Okay. So when you bring it into this reaction, what it will do is that it will cause something at this what center. It will cause something here. It will cause something here. What will it cause? This oxygen will be like they are in gaseous form. Elementrical, looking at it in a simple way, this oxygen will follow this to form, that is, this bond and this bond will close. Oxygen and this will combine to form you this. Then we'll be having something like this. Then the remaining one and this one will also combine to form you see now. That is it. Where this R1, R2, R3, R4 can be hydrogen or any alkyl group. You know, alkyl group, something like this, it means an alkane that have lost one hydrogen atom, so to speak. So first, with this condition, it gives you an unstable compound, this and this, and from there it turns to this. The fragments recombine to give you this in this form. Then from here, any of these can what? Be brought into the reaction to give you the fragments. So this can be, it can produce an aldehyde or ketone, or another aldehyde or ketone. That is what we are saying. Then in this from here, if this reaction as is giving you this product down or this product, you can bring in a reducing agent. Once you've produced this one, you can bring in a reducing agent here. When you bring in reducing agents here, reducing agents like sodium tetrahydroborate or lithium tetrahydroaluminate. These are examples of reducing agents. What these reducing agents will do is that it will reduce these products to either primary or secondary what? Alcohol. So it will reduce it to R1C, R1C plus R1C so it will reduce them to alcohol. How did we come up with this? This is either primary or secondary. And this is either primary or secondary. Now, how did we come up with this information? We came up with this information because we say that when you talk about reducing agents, we have what we call reducing agents, something like this and this, right? Now, these reducing agents we talk about, what they do is that something like when you have let's say ethanoic acid as a case study now, if you introduce strong reducing agents here, this ethanoic acid will get to ethanol and get to what? Ethanol as sap. Like it will get to ethanol as the final product when you use a reducing agent, when you introduce a reducing agent to ethanoic acid. But when you have ethanol, if you want to get ethanoic acid from ethanol, you have to use oxidizing agent, strong oxidizing agent. When you use strong oxidizing agent and apply here, something like KMNO4, this is an example of strong oxidizing agent. That is potassium tetraoxo manganate, right? Okay. When you introduce it here, what it will produce is ethanoic acid, because this is a primary alcohol or primary alkanol. Ethanol is a primary alkanol, so it will give you ethanoic what? Acid. Now, there is what we call mild oxidizing agents. When you are using mild oxidizing agents, so to speak, on here instead of strong, assuming I introduce mild oxidizing agents such as, if I'm using, let's say, H2O2, this is a hydrogen peroxide. If I'm introducing mild, M-I-L-D, mild oxidizing agent. Now, if I'm using mild oxidizing agent in this reaction, what it will give is ethanol. It will not have the tendency to what, or the ability to convert it to ethanoic acid. Okay, it will now convert it to ethanol. Only the strong oxidizing agent converts it straight to ethanoic acid. You know that as this one want to convert ethanol, it will convert it to ethanol, to ethanoic acid, ethanol, then to ethanoic acid. Are you getting it? Let's write it. So this is the final product you will be getting when you do this reaction using strong oxidizing agents. But when you use mild oxidizing agent to oxidize ethanol, if you are using mild oxidizing agent to oxidize ethanol, what you will be having is it will stop at ethanol. Yeah, because if you are using mild is not too strong like strong oxidizing agents. So I want you to note this as we are talking about this topic. Okay, when mild oxidizing agent is used, what will possible product, and when strong oxidizing agent, and this is an example of mild. You can get more examples. Mild example is hydrogen peroxide. So it goes that way. Now, if it is a secondary ethanol, that secondary alkanol that we are talking about, if we are talking about secondary alkanol, what do we mean by secondary alkanol? Secondary alkanol simply mean an alkanol group that have, this is the central carbon, right? Now, as this is our central carbon, this is our central carbon. Okay, central carbon here. This is CH3. Now, we are saying that these two places can be hydrogen, hydrogen. When it is hydrogen, hydrogen, it is ethanol. Now, if one of these hydrogen is replaced with an alkyl group, and here remain hydrogen, this is a secondary what? Alkanol. We call it prop 2-ol. We can call it prop 2 or this scheme is IUPAC nomenclature. Prop 1, 2, 3, 3 carbon. 1, 2, 3, prop 2 or 2 or mean that the whole H is found or is seen at what? Carbon number 2. Are you getting it? Now, this is an example of secondary alkanol, so to speak. So, propan 2 or propan 2 what? Or is a secondary what? Alkanol. Now, when you have propan 2 or, which is a secondary alkanol, and you apply a strong oxidizing agent to it, if you apply a strong oxidizing agent to it, what it will do is that it will oxidize it. It will oxidize it. If you apply MnO4, it will oxidize it to ketone group. You know, this ketone group is what we call RCOR. This is what we call ketone. This is what we call ketone. Okay? So when you oxidize secondary alkanol, it will give you what? Ketone. Are you getting it? It will give you ketone because of this is RCOR. RCOR. This hydrogen will go at that time. So it will give you ketone. Okay? Now, if you further oxidize it, it will not give to what? Alkanoic acid. No. So what I am saying here is that when you oxidize primary alkanol, the final product will be alkanoic acid, which you are seeing here. Then when you oxidize secondary alkanol, the end product of it will be what? Ketone. Ketone. It will give you ketone. Yes, it will give you ketone. And how do we represent that ketone now? From propan 2 or when you oxidize it, you will be having CH3, COCH3. That is what we mean by RCOR. CH3, COCH3. It will give you this as a product. Yes. Then further oxidation of this. So if you are using strong oxidizing agents, it shows that it will oxidize it to the last bus stop, to the end point of it. So using strong oxidizing agent to oxidize propan 2 or will be giving you a ketone. Are you getting it? Yes, it will give you a ketone. Yes. Now, when we are talking about tertiary alkanol, we have talked about primary own. This is primary alkanol. Then this is secondary alkanol, and we are talking about this tertiary now. When we talk about tertiary alkanol, the implication is that under the tertiary, this last hydrogen atom, the replaceable hydrogen atom here, it will be replaced with what? CH3, an alkyl group. So it is already saturated. The central carbon is saturated. The hydrogen at the central carbon is saturated. So once you have it like this and you oxidize it, no reaction will occur. Yes, no reaction will occur. Do you get what we are saying? Tertiary alkanol, when oxidized using strong oxidizing agent, no reaction will occur. But secondary alkanol, when oxidized using strong oxidizing agent, will only form you ketone, depending on the name of that what? Secondary alkanol. If it is propan 2 or, it will give you what? CH3COCH3. That is a molecular formula. That is molecular formula of what it will give. Then if it is primary alkanol, when you oxidize it with strong oxidizing agent, it will be giving you straight to what? Ethanoic acid. It will give you straight to ethanoic acid. So you should know which of these alkanol, primary, secondary, tertiary, which of them will get oxidized to alkanoic acid. The answer is primary alkanol. Then the one that will get oxidized to only to ketone is secondary alkanol. Ethanol, ethanol. If here is ethanol, ethanol. Are you getting it? It means that if we are talking about ethanol here, when you put strong oxidizing agent, it will what? Oxidize it to what? Ethanoic acid. You will be having two molecules of ethanoic acid. Yes. But if here, if here is a ketone, this is ketone, this is ketone. If we are getting here to be ketone and here to be ketone, the implication is that when you put strong oxidizing agent, it will not oxidize further. That is what we are saying. Remember, I say here can be primary. If you call here primary, the implication is that what you have here is CH3 will be down. We are talking about if here is aldehyde and here is aldehyde, we can further oxidize. If you put strong oxidizing agent, we can further oxidize. Let me show you the example of the aldehyde I mean. Here C and here what? O. So this is RCHO. RCHO. This is what we call ethanol. This is ethanol. So once the R1 is H and R3 is CH3 and this remain, we call it ethanol. Then this is gotten from what? Primary alcohol. Look at it. We got it here. Now, what it means is that when you put strong oxidizing agents to this, it will oxidize. It will oxidize to what? Ethanoic acid. Then if these two also, this one is also ethanol, the same thing will happen. Once it is a what? Primary alcohol. Once something is a primary alcohol, once something is primary alcohol is gotten this way. This is primary in the sense that there are two free replaceable hydrogen ion bonded to the central carbon. Two free. For secondary, we have only one hydrogen ion. This is for secondary. Then for tertiary, we don't have any free hydrogen what? Ion. For tertiary, this is tertiary, no free hydrogen ion. Everything is alkyl group. Are you getting it? Then for primary, it has two free hydrogen ion. Now, if here too is ethanol, it means that it's coming from what? Like when you oxidize it, you'll be giving ethanoic acid, and when you reduce it, it will be giving you ethanol. That is why we say under reduction, it will give you that primary or secondary what? Alkanol. Like if here is aldehyde, when you oxidize it, it will be giving you what? Alkanoic acid, because aldehyde can further oxidize. But when we talk about ketone, if here is ketone and here is ketone group, the implication is that assuming a form this one, this is CH3CO CH3. Are you getting it? That means if I should represent it, look at what we have there. We'll be having CH3 CH3. This is prop 2 on 1 2 3 propan 2 what on propan 2 on. That is about the ketone. Assuming we have propan 2 on here and we have propan 2 on here, ketone group. When you further oxidize it, nothing will happen. It will stop at what? Propan 2 on. But when you have ethanol as a product you got from ozonolysis, and you further oxidize it, both of them will be giving you alkanoic acid. That is ethanoic acid. I don't know if you are getting what I'm saying. See, ketone, further oxidation will not have any effect. There will be no reaction. It will remain ketone. But aldehyde. Further oxidation gives you what? Ethanoic acid, that is alkanoic acid. If this is ethanal, further oxidation gives you ethanoic acid. If this is propan 2-one, further oxidation of it gives you what? No reaction. It will remain propan 2-one. So you need to understand the drama that is going on ozonolysis of alkene, because when they give you question, you need to understand what is actually going on. I will give you an example. But remember, when I talk about mild oxidizing agent, mild oxidizing agent doesn't work like strong oxidizing agent, so to speak. You now say that what the strong oxidizing agent will do, it will take straight if it is a primary, but the mild one will not take it straight. It will stop on the intermediate. Are you getting it? So you need to remember all these points. They are very important when it comes to ozonolysis of alkane. Now we'll give a question on ozonolysis of alkane, and we'll now see how we can sort it out when alkane is what? This and that. What will be the product? Let's look into this question and see how we can understand what we'll talk about. Once I see question on ozonolysis of alkane, just O3, this is ozone. Are you getting it? Once I see question on ozonolysis of alkane, what I should do is to go to the what? The double bond. You see the conditions, the catalyst involved. As I'm seeing this catalyst, what I will do is that I will go to the double bond, meaning that ozonolysis is taking place. I will divide this double bond into two. That is what I will do. The first one, I will attach is 0, and the second one, I will attach is 0. The first one, I will attach is 0. Or I will now write everything as it is. 1 CH3 CH3 H. This is what the first one will give you, plus the second one. I will also put it to be, this is, I will just put 0 for this and 0 for the other one. That 0 is oxygen, so to speak. I will attach atom of oxygen to this half of it and the other one as it is. Okay? Then I will now say CH3 CH2 CH3. These are the two products it will give me when ozonolysis of this alkane group take place. So instead of me wasting my time drawing the unstable aspects and the molozonite, the ozonite, and all have you, I will just go straight, bam, because I'm dealing with OBJ exam. But if you are dealing with theory, you can exhaust it, trying to show the what? The molozonite, the ozonite. Like, I'll just come and tell them CH3 CH3. Okay, and here is okay, let me put it well. CH3 H3. Then can you see what I'm doing here? CH3 CH2 CH3. This is what we mean by ozonite. This half of this oxygen will join this to close up to form this. Then the other half will join this to close up to form this. So this bond will go like this and the other bond will go like this. That is all we have here. Are you getting it? Now, what is the name of this? What is the name of this? We say this is ethanol. Is it ethanol? RC RCHO. Is this ethanol or is this alkana or alkanone? That is what we want to check out. This means 1, 2, 3. Propan 2-one. This is what we call propan 2-one. That means there shouldn't be hydrogen here. There is 2, 1, 2. This is complete. So there is no need of hydrogen here. Yes, because this is 1, 2. Yes, so it's an error from me. There is no need of hydrogen here. So you have, okay, we want to just understand what we are trying. Using that only 4 bonds, 2 here, 3, 4. 2 here, 3, 4. So no need of hydrogen. Okay, so this is what we call propan 2-one. Propan 2-one is a ketone. Propan 2 what? One. Are you getting it? Or 2-propanone, or you can call it 2-propanone. You understand? It is a ketone. Then this one, as I said, there is no hydrogen here. So this one is also RC. So this is a ketone too. 1, 2, 3. Okay, 1, 2, 3, 4. 1, 2, 3, 4. Both 2-one. Butan 2 what? One. This is a ketone. Are you getting it? So since it is butan 2-one, 1, 2, 3, 4. Instead of me saying 1, 2, 3, 4, I'm giving this a higher number. I say 1, 2, 3, 4, making it that this is 2. The other one, this is 3. So butan 2-one. Are you getting it? It's a ketone too. That means in the ozonolysis of this, it gave us 2 ketone group. So if they are telling you that when the product is what? Oxidized. If you oxidize these 2 products with KMNO4, if they are oxidized with KMNO4, no reaction will occur. No reaction will occur. Because you can't oxidize ketone. That is what we are saying. You can't oxidize ketone. You can only oxidize aldehyde to alkanoic acid, but you can't oxidize ketone. But you can reduce it. You can reduce ketone. If I'm reducing this ketone, because they are ketone, if I reduce it, it will give me secondary alkanol. It will give me secondary alkanol, because it is only secondary alkanol that when you oxidize, it gives you ketone. So when you reduce ketone, it gives you secondary alkanol. Are you getting it? So that means that when I reduce this one, if I reduce it with if it is being reduced with, let's say, lithium tetrahydroaluminate. So if it is reduced with this catalyst, the implication is that we'll be having propan 2-ol, a secondary alkanol. When you reduce ketone, you get propan 2-ol. This one, when reduced, it will be giving you butan 2-ol. When reduced. So be able to know when oxidizing agent is applied, what will be the outcome. And when reducing agent is applied, what will be the outcome. In this one, oxidizing agent will do nothing. Are you getting it? Because you can't oxidize ketone. Whereas reducing agent, like using this, when you reduce this ketone, it gives you butan 2-ol. Or when you reduce it to give you propan 2-ol. That is what we are saying. Yes. Now we'll come to this. The same thing will happen here. The same thing happens. You divide this bond, because ozonolysis will go to break that double bond. Now when this double bond is being broken, you will be having the first one, CH3C0, oxygen. You put oxygen for the half of the bond, plus what? You do again the half, you put this oxygen there, CH what? 3. What do we call this? This is RCHO. This is ethanol, an aldehyde. Ethanol is an aldehyde, and this one is ethanol too. Ethanol. Now, if this is the outcome of this ozonolysis of this reaction, now if peradventure you introduce a strong oxidizing agent here, what it will end up to do is that because this is aldehyde group, if you introduce KMNO4, it will oxidize this to ethanoic acid. It will oxidize the first one to ethanoic acid, and it will oxidize the second one to ethanoic acid. So we will be having two molecules of ethanoic acid produced. That's what we are saying. Yes, because this is primary. This is gotten from primary alkanol. That is ethanol. It is gotten from it. It is ethanol, which is primary alkanol, that you can oxidize to ethanol, then to ethanoic acid. So you can easily oxidize ethanol to ethanoic acid. But when you are introducing a reducing agent here, if you reduce this, if you want to reduce this, it's possible. Reducing agents, when applied here, will reduce this ethanol to ethanol, a primary alkanol. It will reduce it to ethanol, a primary alkanol. And it also reduce this one to ethanol too. It will reduce this to ethanol, that is primary alkanol. So reduction can take place here using a reducing agent, and oxidation can also take place here using a strong oxidizing agent, such as KMNO4, K2CrO7, K2CrO7. You can use either this or KMNO4 to oxidize. But for this first reaction, because it gives you ketone, you can't oxidize it, but you can reduce this to secondary what? Alkanol. Be able to know which it will give you and the condition involved. Okay? Yes, that is about ozonolysis of alkane. We will post more videos on reactions so that we will learn more. Thanks for watching the video. If you find this video helpful, please don't forget to click subscribe, share to your friends, comment, like the video. Okay, if you want to gift, no problem, we appreciate. Thanks for the ones you have been doing. See you in the next class.